The Kruskal-Wallis test is the non-parametric equivalent of the independent ANOVA. If an assumption for the independent ANOVA has been violated, you can choose to conduct this non-parametric alternative, namely the Kruskal-Wallis test. The test statistic h is calculated as follows. H equals 12 divided by n multiplied by n plus 1. And this fraction is then multiplied by the sum of ri squared divided by ni, minus 3 times n plus 1. N stands for the total number of participants, and the small n stands for the number of participants within a group or condition. R is not the correlation here, and R squared not the explained variance, but Ri stands for the sum of ranks for each groups. You have to calculate the sum of ranks for each groups, square this value, and divide it by the total amount of participants in that group. Do this for all groups, and then add the scores together. You then multiply the score with 12 divided by the number of participants multiplied by the number of participants plus 1. Finally, you subtract 3 times the number of participants plus 1 from that total. And let's do that using an example. In the table you see the participant numbers 1 through 9, and the participants are divided between 3 groups or conditions. There are 3 participants in each condition. In the column y, you can see the scores you measured on your dependent variable. To fill in the formula, we will start with the first fraction. 12 divided by n times n plus 1. N is the total number of participants, which is 9 in this case. And so we calculate 12 divided by 9 times 9 plus 1. 9 plus 1 is 10. 9 times 10 equals 90. So we end up with 12 divided by 90, which is 0.1333. And then we need the rankings, or rank values. The observation with the lowest y value is assigned rank number 1, and the observation with the highest y value gets the highest rank, which is in this case 9. If we then look at the y values, you can see that 2.5 is the lowest value, and this observation will thus get rank number 1. The next value, 3.4, will get rank number 2. Next value, 4.1, will be assigned rank number 3, etc., etc., etc. And this way we're going to be filling the whole column. And next we need the sum of ranks for each group. For group 1, this is equal to 1 plus 2 plus 5 is 8. Group 2, 9 plus 4 plus 7 is 20. And group 3, 3 plus 6 plus 8 is 17. And then we're going to square the value for each group, and we divide that by the number of participants in that group. So 8 squared divided by 3, plus 20 squared divided by 3, plus 17 squared divided by 3. And this equals 64 divided by 3, plus 400 divided by 3, plus 289 divided by 3. Which will equal 21.33 plus 133.33 plus 96.33. In total, this will equal 251. We can fill in this value in the original formula we started with, and this becomes 0.133 times 251 minus the last part of the formula, which was 3 times capital N plus 1. And capital N is the total number of participants, in this case 9. So 9 plus 1 equals 10, and 3 times 10 equals 30. And then we have 0.133 times 251 minus 30, and that equals 3.47. And thus the test statistic is 3.47. The Kruskal-Wallis test has a chi-square distribution, and therefore the degrees of freedom are calculated using k minus 1, where k is the number of groups. In this example, there are 3 groups, so there are 3 minus 1 is 2 degrees of freedom. Based on these degrees of freedom and the test statistic, you can look up whether there is a significant difference between the groups.